Pi there. So in this video, we'll be doing again hyperbola, but this time we'll be trying out more challenging examples than before. So before that, we first recall that previously we learned the definition of an hyperbola. So a hyperbola is the set of all points in a plane where the absolute value of the difference of whose distances from two fixed points f1 and f2, which we call the foci, this one, is constant. So again, to illustrate what it means, let's take an arbitrary point, take its distance to f1 and then to f2. What the definition means is that if we subtract these distances, take its absolute value, it must be equal to a certain constant, let's say c. And that must also be true if we consider this distances of this point. Aside from the definition of a hyperbola, we also learned the following parts involving it. So the first is the center. Basically, it's the midpoint of a line segment connecting the two foci. It would be this. The vertices, this is the points of intersection of the hyperbola and the line through the foci. So in our illustration, it will be this and this. Third is the transverse axis. It is the line segment connecting the two vertices, which is this one. After this, we also learned about asymptotes in a hyperbola. So a hyperbola has two asymptotes, specifically this one. This one is the positive version and this one is the negative version. It's basically the same formula, same equation, just with different signs. What it tells us is the behavior of the hyperbola as it extends towards infinity. So for instance, if this extends here and this here, the asymptote tells us that the extension of the hyperbola would not cross the asymptotes. Now that the parts of the hyperbola are out of the way, we now move on to the formula sheet for the hyperbola. For our discussion on the examples today, what's important here is this one, the equation, and the equation of the asymptotes. So again, just to recall, the distinction between these two is that this first formula tells us or gives us the hyperbola that is oriented like this. On the other hand, this version tells us the hyperbola that is oriented something like this. So that is just a brief recap of what happened last video, and this time let's go on to the more challenging examples. We start with this first one. For this first one, our goal is to find an equation of a hyperbola centered at the origin, a focus at the point 50, and a vertex at the point 40. So the key in solving these types of problem is to first list out what you are given. So based on the given, we have first the center. The center is given by the point, let's denote it by C, and since it is the origin represents the point 0, 0. Next, the focus, we denote the focus by F as usual, and the vertex to be 4, 0. Using this tree, we can determine the equation of our hyperbola. We establish next our goal, and our goal is the equation of a hyperbola. So to do that, we first recall the equation of the hyperbola. In the equation of the hyperbola, we have two versions. One that is either for like the horizontal version and another for like the vertical version. To determine which one we'll be using, we just observe what happens out here. So observe that if the center is at 0, 0, take note that the foci and the vertices are obtained from the center by shifting the x-coordinate. This means that the vertices are out here and the foci are probably out here, which means that we expect that our hyperbola would look something like the horizontal version. If this is the case, take note that in the formula, we will be having x minus h squared minus y minus k squared. So the minus part is on the y variable, since it's like we omitted the axis that is parallel to the y-axis. Then for the a and the b, always take note that the one with the positive variable would have the a denominator, a squared, and the one with the negative variable would contain the denominator, b squared. This is equal to 1. Given this, we can easily obtain the equation. First things first, take note that h and k here represents the center. Our center is already given. We can substitute that immediately. So we'll have here x minus 0 squared minus y minus 0 squared. Our only problem is the a and the b. But recall that to obtain the vertex, what we add here is basically a, which means that the 4 out here, 4 is equal to the a. So we can immediately plug it in out here. So our only problem is b. But recall that for the foci, what we add here is the c. 5 is equal to c. And recall that c is given by the formula square root of a squared plus b squared. This will be our working formula to solve for b. Take note that if we square both sides, we will obtain 25 equal to a squared plus b squared. A squared is something that we know. Since a is equal to 4, then basically 25 is equal to 16 plus b squared. Move this to the other side, we will be obtaining 9 equal to b squared, and actually we don't really need to solve for b anymore since what we need is the b squared. So basically, we have determined that this one on the denominator will be that. Simplifying this, the equation of the hyperbola described in this problem is given by x squared over 16 minus y squared over 9 equal to 1. That is the answer for this problem. Let's move on to the next example. Our goal is to find an equation of a hyperbola again, with center at origin again, but this time what we have is the vertex at 8, 0, and asymptotes with equations given by this. So similar to earlier, we express or we write the given. So the given is the center, we denotes by C, the vertex, one of the vertex, 8, 0, and the asymptotes, given by 2x plus minus 4y equal to 0. So in here, since our goal again is the equation of the hyperbola, let us recall the following. So what version of the equation would we use in this case? Like earlier, the horizontal version. Why is that? Observe that if the center is 0, 0, to obtain the vertex, we shifted its x coordinates. So the vertex is somewhere around here, which means that we expect the hyperbola to look something like this. So we just copy the formula earlier. Let's now go on to the equation. Similar to earlier, it is easy to see that h and the k here would just be given by the center 0, 0. So just like earlier, we can write this as x minus 0 squared minus y minus 0 squared. And then here, recall again that in the vertex, what we add here is the 8, which means that this one is just equal to 8 squared. This time, our problem is the b, but recall that we still have this equation out here. This thing here, let's move 2x to the other side. We will obtain plus minus 4y equal to negative 2x. Afterwards, take note that we can divide plus minus 4 on both sides. If we do that, we will get just y out here. Then take note that if we have negative out here and we divide a plus minus version, what we will get is still something like plus minus. Why is that? Basically, if it's negative times negative, you get the positive. If it's negative times positive, you get the negative. So in either case, we still get plus minus. Take note that we can express this further as y minus 0 equal to plus minus 2 over 4 times x minus 0. But recall here that in the formula, this here represents the denominator of the y variable. In this case, that would be b. So this one must be equal to b, and 4 out here must be equal to 8. But our a is given by 8. So how do we match that one? You guessed it, we simply just write 2 over 4 as 4 over 8. These two stuff are the same, but the good thing about this is that this one matches the a that we have. If that is the case, then we now know that this one, the b, must match what we want. So basically, the b that we are finding here is 4 squared. Simplifying, we can write the equation as x squared over 8 squared, or 64, minus y squared over 16 equal to 1. That is the answer for this problem. So those are our examples for today. To end this, take note that I have a feedback form attached on the description or the comment section down below, and you can answer that one to help me provide better math content to you by answering that form in the description down below. If that is too hassle for you, you can just simply comment down below your comments, and I'll be glad to read that one and get better for your benefit. So yeah, that's it. I hope you enjoyed this video, and yeah, have a nice day.